Okay, so it's the next day. I want to make a correction. This component is not an inductor, that's actually a choke or a filter of some sort. It looks like the pure sine wave goes through that. But in any case, the inverter won't work if this is broken off, and it is common for something like this to break off. They tend to be heavy, and they will break off, and then the inverter has no output anymore. So it's something to always check. And you can also check on the other side. Sometimes the solder joints break. So it's just something to be aware of. Anything like this is large and heavy and freestanding could break off. Okay, so the next part of the video is how to probe a MOSFET, which is a big part of these types of circuits. And a MOSFET is just an electric switch. So it has 3 tabs on it, or connections, usually. And you have a source, a drain, and a gate. Source and drain are just the input and output for the current to flow. And the gate is what allows those two to connect together. So you apply a charge to the gate, the switch activates, and the source and the drain can pass current. But that can be done very quickly. They can be switched very rapidly, so they're considered switches. And if they fail, of course, this inverter won't work. This inverter is heavily based on, well, MOSFETs. Without MOSFETs, you don't have an inverter. And there's quite a few of them. Now, some of these are diodes, and you can see there's a whole row, but some of them are diodes, and they may look the same. They may have the same type of package. And the connections are on the other side. So how do you identify which is which? Well, we know the gate is just a switch, and therefore it must not take much current or power. It doesn't take much actual power and wattage to turn a MOSFET on and off of this size. But the source and the drain are a relatively large current because it's basically that's what a transistor or a switch does. Use a small current to switch a large current. So here are the 2 inputs, MOSFETs. And you can see right away there's a large area of copper right here. And that large area of copper is tied to these pins here. There's 2 MOSFETs side by side. They're working together. And you can see the second one connects to another large pad right here. But this third one, see if I can make that clear. Not going to be, oh, there it is. The third one of the 2 pairs appears to be not connected to anything. And that's because it's connected to a trace on the other side of the board, I believe. I'm going to try turning around. Now it's on this side. And I don't think I'm going to be able to show it. Yeah. Let's see if I can get away with it. Unfortunately, no. Very difficult to show this on camera. But trust me, it's easier to look at the other side. Trust me, on this pin here, there's going to be some other components. I believe there's a resistor and another small transistor that provides the gate charge or the gate current to the switch to turn it on and off. So we know these 2 pins here and these 2 pins here are the MOSFETs, and they have to be the source and the drain. I don't really care which is source and which is drain in this case. I just want to check one thing. Are they shorted together? And very, very common for the source and the drain to become shorted out due to a failure or an overload or overheating condition. And so once you identify the source and the drain, probe that first. Don't probe anything else. Don't probe the gate because a multimeter has a small amount of current it outputs. And you could actually activate the gate by accident using your multimeter, and then you would be getting a false reading when you probe the source and drain finally. So let's give this a try. Okay, so I put my multimeter on ohms, and I'm going to try to measure the MOSFET. Now this one here has been cut out of circuit, but I can measure this one, and I don't believe this one has failed. So let's go ahead and give it a try. I'm on 2,000 ohms right now, and you know, I'm getting a reading. It's certainly not 0. It's not 0. So I'm getting a non-zero reading. Now this MOSFET is in circuit, and you have to keep that in mind when you're measuring a component that's in circuit. You could be measuring other components too and not know that. But this MOSFET over here, I cut it out. It was reading close to 0 ohms. It was basically a short circuit. And this whole board would not work until I cut this out because it was shorting everything out. So that's how you probe a MOSFET. And you just use ohms on your multimeter. I'm using the 2,000 ohm range. It's really not an exact science. It's just kind of like you're looking to see if it's a short circuit or not. And if you find it's an ambiguous reading, you can just replace the MOSFET. It's usually a couple bucks. It's not worth blowing up more stuff because you didn't want to replace one $2 MOSFET. So both of these MOSFETs here, when I get ready, they're both going to be replaced with brand new ones, because since this one neighboring it blew up, I don't want to trust that something maybe didn't happen to this one. I'm just going to go ahead and replace it. And that's generally how I look at it. And it's cheap insurance. If you're going to do all this work, you might as well spend another $2 and a few more minutes to put another one in. Now you can also probe the gate. Now you never want to see continuity, low ohm continuity between the gate and any of these other pins. If you do, that's a huge red flag. That's a big problem. And I'm trying to push really hard on this to make good contact. There is no connectivity between the gate and the other two pins, and that's also correct. Now, if you do find that you have connectivity between the gate and one of the other two pins, or both, you have a big problem, because in many cases that means the MOSFET shorted out to the gate. That means that high current could have flowed over to the drive portion of the circuitry, which is where the gate is connected. That means you could fry the upstream transistor, the resistor, and then the IC that's behind that, driving that transistor which drives the MOSFET, could also be fried. My personal preference is, if I find that to be the case, I don't bother continuing with the repair. I don't feel like it's worth it, because you could really chase your tail for a week trying to repair an inverter board like that. And then even if you do find out the problem and you have a fried IC, integrated circuit, a microchip, in many cases you can't even get a replacement, because it's kind of semi-exotic or proprietary, or sometimes they'll sand the top of the chip and you can't read what it is. Your only option in that case is to try to find another inverter board that does not have the same type of failure, and try to lift the IC off of that board and use that as a replacement. It just seems like that's too much effort. You know, it's a balance between getting your money's worth and learning a little something and not turning into a huge headache. So that's just my personal opinion. But on this board, I don't think that happened, and you can see there's no continuity between the gate and the other two pins. So I'm fairly certain that didn't happen. So that's just a gotcha to keep an eye out for. If you're going to try to do repairs to a board like this, remember there is a such thing as going too far. And you have to cut your losses and just do something else. Take what you can and cut your losses. So this video is getting really, really long. My plan is to replace, this board is mostly functional now, but my plan is to replace those two MOSFETs that I showed you, and get this board running 100%. So the only thing I can't use on this board right now is the inverter stage. But actually putting in the MOSFET and all that stuff is going to be out of my reach at the moment. I don't have the MOSFETs yet, but this video is already getting very long. So I think I'm going to have to break it into parts anyway. So the next part of the video would be, let's just assume that you decided not to repair this board, and you just feel like it's not worth it. You decided to abort the repair. Then the last resort is, if you paid for this board, you paid for this solar generator, what do you do with it? Well, in my opinion, the best thing you could do with it is to salvage it. So that's the last part of this video, salvaging. If you cannot repair, if you cannot effect a repair of the system, don't throw it away, because there's a lot of good components here. So the most important components are these large capacitors, the inductors and filters and things like that, any kind of plugs or jacks, the heat sinks, the MOSFETs are useful, the transformers, of course, all the plugs. The circuit board itself is effectively useless unless you want to practice your soldering skills. And after that, you kind of run out of components that are worth pulling. You do have these diodes, you can pull those. The opto-isolators, I don't know if they're worth pulling. Then what I would do is I would just stack these boards in a box somewhere and keep them for surface mount components. Because if you ever do surface mount rework, you know, there's a lot of little components on here you can lift, and I've done it before. You can just lift the components off the board, and instead of buying them. But it may not be useful to you to do that. Maybe you'd rather just buy clean new ones and go from there. These little daughter boards, I'm not sure they have anything useful on them. That would just be up to the person doing the salvage. All the hardware and screws on here, the screws, I would save those clamps for the MOSFETs. The plugs and wires, silicone wire. These are very nice silicone jacketed, probably high-strand tin copper wire, I'm guessing. Very nice flexible wires. Nothing at all wrong with this wire. This is a JST, I believe this is a JST XH plug. It's very common and very useful. You could probably make a balance plug for a LiPo battery out of this. If that's JST, I don't know for sure. I think it is. So, certainly these boards are worth salvaging. So in the next part of the video, I'm going to talk about the rest of it. Most of the action is going on this board here, obviously. But there's still some circuitry left in the solar generator. So let's look at that next. Okay, so here is the rest of the unit, and it's a plastic shell. It actually comes off right there. It separates. See the batteries in there. And there's a base. This is where the bolts go into. And on the front you have this faceplate, and believe it or not, this faceplate is loaded with electronics. Now in all the units I purchased in non-working condition, they were dead as a doornail, but in all of them there was nothing electronically wrong with the faceplate. One of them was melted, but it was still, I was able to revive it. I had to take it apart. But there's actually quite a lot of electronic components in there. And you can see back there is a heatsink right down there. You see that metal piece that I'm putting my finger down on. And there's actually MOSFETs in there. And so what those are for is on the front of the unit you have your 12 volt output at 8 amps. That's a cigarette lighter outlet. Not for lighting cigarettes, that's just the term used. That's its original purpose, and nowadays it's just used for providing power. And it's not a very good power plug format because they get really hot. I mean, 8 amps, yeah, it's probably going to get really hot. So you have basically a MOSFET that's behind here, and it just connects this to the 12 volt battery pack inside and gives you 12 volt nominal power. This is kind of unusual, and I really like this. It's a 24 volt 3 amps, so there's a boost converter on this faceplate that's putting out 24 volts at 3 amps. Now that's useful for a lot of things. I've used it for charging other smaller batteries. I've used it for running power supplies and whatnot. And then here you have 3 more plugs that are 12 volts. These also connect straight to the battery pack. When you push this button, it connects. And that again uses a MOSFET. It's just a switch, so it just turns the MOSFET on, keeps it on, and it probably has a current shunt in there to measure the current, make sure you don't pull more than 4 amps, 3 amps, or 8 amps, depending on which output. And then you have probably 1 to 2 buck converters to feed these USB ports, and these just knock the 12 volts down to about 5 volts. Now these are USB 3.0 quick charge. If you look, there's an icon. And I actually don't have the newer smartphones. I have a smartphone, but not the kind that has a huge battery in it. And the newer smartphones are very power hungry. And so that's the reason why you have all these newer USB ports. There's a new one out now. It's USB-C, USB power delivery. You can get like 45 watts out of it. I don't think you can get 45 watts out of this kind. So that's a nice touch. This is a really nice unit. It's loaded with functions. And of course you have the inverter. I've got it covered in tape. This is the AC outlet. That's covered in tape because I don't want to accidentally turn it on while it's in a broken condition, because you will blow the fuse. Or at least there's a chance you will. So the rest of this unit, I'm going to say it's not super interesting. There's a lot of electronics on this board, but in my experience, nothing goes wrong with them. This board is interesting though. It's very tedious to take apart, and it's very intricate, and you have to get everything just right. And once again, just a warning about those LEDs that are on the board. They're very dangerous once you take the diffuser off. So if you do take this board apart, you have to be very careful. Now as far as salvage, there's not a whole lot on this board. You get some MOSFETs, there's a heat sink, there's some wires. You can't do a lot with the display. There's really not a lot on there. So that leaves the battery. So the battery is, let's say you pay $100 for a unit like this, and it's in 4 parts, not working condition. So the battery is probably, in my opinion, one of the top draws of this unit. If you can't get it to work, this battery is probably worth your effort. It's going to have 30 18650 cells in it. This particular one does. Of course, they're all different sizes. So let's talk about salvaging the battery. Yeah, that's in the next part. Okay, so here's another battery. This is not the same type that was in the solar generator I just showed you. This is another one, but it's pretty much the same story. And you can see the cells there. And there's 10 in each group. Now there's a lot of interesting options. If you have a battery like this that's good, don't throw it away. The 18650 cells, let's say they're worth a couple dollars each. There's $60 right there. So that's one way to look at it. So a battery like this, I would consider it worth more in one piece than taken apart. So let's look at the salvage technique where you tear it to pieces. You get the cells out of it. This board here is probably not going to be worth much to you, and you get these wires. Now I added this cable here myself, but you know, you get these wires, you get some plugs. So I don't think a lot of the components on here would be worth a lot, but you could still stack this board somewhere and keep it for later purposes. So salvaging the battery pack is probably the easiest job, and it's very common for people. They spend hours. It's very popular these days to salvage 18650s. I've seen guys that just have absolute bins of them. It's a very popular thing. I prefer to use larger cells. I do have an off-grid power system, a pretty large one, but I use large format cells. I don't have the time. However, these are useful cells, and these particular ones are 2600 milliamp hour if you believe the nameplate rating. They're just generic cells. So I don't know. That's not a name I'm familiar with. XRWHZY. I'm guessing that's, you know, a Chinese province or something. You know, they're obviously Chinese cells, and some of them can be good and some of them can be bad. But I think these are good. These solar generators are at a higher price point, and they tend to use better equipment inside. So I would suspect these are decent cells. So if you don't tear the pack apart and take the cells out, the question is then the BMS. Now there are different kinds of BMSs. Some of them require a signal or some kind of action to turn them on, and until you do that, they're basically dead. This particular pack, though, I actually like because it had a BMS that's always on. As long as there's nothing wrong, it stays active. So this is actually a very nice pack. Let's say you have 10 cells and they're 26 amp hour. I'm sorry, 2600 milliamp hour. The lighting is making it very hard. 2600 milliamp hour. That's 2.6 amp hour, and you have 10 cells. That's a 26 amp hour pack. Of course, you're not going to get 26 amp hour without running it down to absolutely nothing. So let's just say it's 21 amp hour. That's almost a quarter of a kilowatt hour of usable energy if you don't quite use the whole pack. Now, lithium-ion batteries, it's better not to charge them all the way up, and it's better not to run them all the way down and stay in the middle 80% or so, and it makes them last a lot longer. Lithium-ion batteries like this have a limited cycle life. And now some of these do have lithium iron phosphate cells in them, and those have thousands and thousands of cycles. If you treat them well, they can last you a lifetime. But still, a battery pack like this would be very useful. So what can you use it for? Well, you could use it to extend your existing solar generator. They have these plugs on here. I forget what these are called. I think they're XT100s or XT90s. I think it's XT100. I don't know, or it's some other form factor. This is a RC vehicle plug, though, or helicopter, remote control helicopter plug. I've seen it before. I just don't know what it's called off the top of my head. And they've just cut it in half. So nice, big, flexible cables. I don't know what gauge these are, but they're really flexible. They're silicone jacketed, 10 gauge. So nice, big, thick wires. So you could absolutely connect an inverter to this, or find a way to connect it to an existing solar generator. So you could use this as an extended battery pack for your existing solar generator. However, that's a bit tricky. You have to be careful. This particular BMS expects to be charged through this cable here, not these cables. This cable here goes through an entirely separate circuit. So you have to be careful. You can't just start connecting wires and leave it that way and go outside while it's charging and think everything's going to be okay. It's kind of dangerous. But the bottom line is you could use this for running an inverter, for off-grid applications. You could use it for solar lighting. Anything you want to do. So if you get a good battery like this, you're successful at least in getting a lot of your money back, because even though the rest of the unit is not useful, you got a really nice battery. And the time it would take for you to spot weld all these cells, hook the BMS up, get it working, get all the connections right, put these huge solder joints on. Well, here you have a pack that's already made and already ready to go. Another interesting fact is there's room for 2 more cells in each group. If you take the foam out, this foam in here, you could increase the capacity by about 4 amp hour. That might actually be worth it. So let's look at the next piece of equipment, which is just the case itself and the faceplate. Okay, so salvaging the rest of it, let's assume you salvage the battery. Now, most people, they might be inclined just to throw this plastic case away. I would never do that, because I happen to be into electronics and I like using project boxes, and what we have here is a A-grade project box. It looks really nice. The only problem is you would have to make your own faceplate, because this faceplate is, you know, obviously you might be able to reuse it or you might not. It all depends on your application. You could take the display out, and you could take some of the equipment out from behind and put your own LCD in here, or your own battery meter. That's a lot of work, but then you wouldn't have to cut a new faceplate. If you own a laser cutter or a CNC or a 3D printer or anything like that, there's a chance you could print yourself or fabricate a new faceplate to go in here. And then once you have done that, you have a really nice project box that looks pro grade. It looks like you really spent a lot of money and a lot of time on it. Well, you probably did. But normally project boxes are just a plastic box with 4 holes or 4 screws in it, and they're very boring looking. They're not exciting at all. So I kind of like to keep any kind of a case like this, because you never know what you're going to use it for. How much is it worth? Well, project boxes can be, a project box of this size would not be $20. It'd probably be more like $30 or $40. So if you take into account the fact you're going to have to do some work to use it, I would say it pays the rest of your $100 right there. And then the rest of it would be this faceplate if you decide to salvage it. There might be a few components on there, but nothing really great. And then the last part is, if you don't want to keep the case, I would keep the bolts that hold it together at the 4 corners, because those are very nice. You can put them through bearings and all sorts of things. They're, if you're into salvage, you probably already have parts organizers, and you have rows and rows of drawers, and you just have everything, and you have long bolts, short bolts, miscellaneous screws and fasteners and so forth. So that's what you would do. And all these wires, you can just reuse that for whatever you want to use it for. So that's the end of the salvage portion of the video. Now I could go on and on and on about it, but I think salvage is pretty straightforward. If you're an electronics person and you want to have extra components around, it's not rocket science. You just pretty much tear out the components you want. I mean, even rocket science isn't that big of a deal. It's just a matter of figuring out what you want, what you're willing to spend a little time taking, and then throw the rest out or throw it in your junk pile. And if you're like me and you don't like to waste, I don't like to waste anything, even a good cardboard box. I can't stand to throw away, because surely I'll find a use for it. Salvage can be fun and rewarding, especially when you start getting enough salvage stockpile where you start going there like your own personal junkyard. You need something to be repaired, you need to fix something, and you've been amassing a lot of salvage, and then you can just go ahead and pick through that and get what you want. And it doesn't cost you, it costs you a little bit of time, but it doesn't cost you any money. And there's something rewarding about having a lot of salvage sitting around and finding you don't have to go buy and pay taxes on something that you could have just had in your backyard if you hadn't thrown it away. And I guess I should include a shot of the case. And these are the bolts, the top of the case, I mean. I think these are called shoulder bolts, and these are really significant bolts, and I would not throw these away. They're hex head, and I would keep them. The other thing that's in here is you have these fans, small brushless DC fans. Probably aren't ball bearing, but still. These are in a lot of pieces of equipment, and they often go bad. Now you could replace a bad fan with a cheap fan like this, or you could go buy a nice Japanese ball bearing fan that would probably never fail. So there's 2 different ways to do that, but these fans wouldn't take you but a couple, maybe 30 seconds to pull them out, and you have some replacement fans. And I would take any of the fasteners that are in here, because it's always handy to have those things. But I think that's about all you could get out of a unit like this, unless you're really just getting every little thing. That would probably take a lot of time. So I hope you enjoyed the video. It got kind of long. It could have been 5 times longer. There's really no way to make a video like this short, I don't think, because then you can't show anything worthwhile in it. So it's really not targeted at people who just want a quick clip. It's kind of nitty-gritty. But really, I just wanted to help people who, number one, or maybe don't have anything to do and are bored, maybe stuck inside, and they're interested in this sort of thing, but they don't want to tear up their own solar generator. At the very least, it lets you see inside of a solar generator without taking yours apart. I do watch a lot of teardowns, and I don't really like opening my stuff. I'd rather watch someone else tear their equipment apart, and mine stays in one piece. And it also functions as a sort of an introduction to repair, electronics repair, if you want to try possibly repairing one of these units if it's in a broken condition. At least it gives you an idea of what to expect, what's on the inside. It's kind of like giving you a little shortcut, a little leg up on the job. So I have 1 or 2 more videos kind of in this direction that are in planning. One is going to be probably just showing different solar generators I own. I have a lot of them. Some I've repaired, some I bought brand new. Probably could do reviews or maybe teardowns of those. I'm also working on a project where I'm going to cook food using a solar generator with no attachment to the mains power. I think that would make a neat video. Okay, so thank you for watching this video, and I'll see you later.